Welcome to the lecture on product design for manufacture. In this session, we are going to see the design for manufacture and assembly in product design for manufacture. In this lecture, we are going to give some insights about what is the design for manufacture and what is design for assembly, and certain guidelines for the design for manufacture and assembly. Basically, we can call it as the design for manufacture and assembly as DFMA. This particularly concentrate on four major things. One is cost of the product, next quality of the product, next time to market, and then functionality of a product. So basically this design for manufacture and assembly will particularly concentrate on four these things. To reduce the cost of the product, to improve the maximum quality of a product, and increase the functionality thus intended to design of the product, and time to market, reduce the time to market of a product. So with this introduction, I will give some basic difference about what is design for assembly and what is design for manufacture. And this design for assembly particularly concentrate on reduce the product assembly cost. So number of products, it will reduce the number of products that will be going to assemble. That is minimize the number of assembly operations, and the individual parts tends to be more complex in design. And design for manufacture particularly concentrate on reduce the overall part production cost. This will be achieved by these two things. One is minimize the complexity of manufacturing operation and use of common datum features and then primary access. These are the major difference between design for manufacture and then design for assembly, and the similarities between these two design for manufacture and assembly. Both this design for manufacture and assembly seeks to reduce the material, overhead, and then labor cost of a product, and they both shorten the product cycle time. And this both design for manufacture and assembly seeks to utilize the standardized to reduce the component. So these are the basic three similarities between the design for manufacture and then design for assembly. And then design improvement example. If you take if you take this example, if you see here, this is a flat plate and this is a cup shaped product, and this will be a fastener. So the ultimate aim is we need to fix this cup shape to the flat plate. For this there are n number of possibilities are there in this functions. So first thing, they will be having some case study for several processes. The first case study indicates that we will be using the fastener assembly. For that fastener assembly, we need three parts to join. One is fastener, second cup shaped product, third one is this flat plate. For this we require screwdriver, and then we need careful alignment, and then it is a time consuming process. This is the case study for the first case one. Second case, if you choose rivet gun to join the cup shaped and then flat shaped product. For if it is a rivet, we need some rivet gun. For the number of products required also three. The one is rivet, and then a cup shaped product, and then flat shaped product, and the alignment is not required. Assembly time is very less when compared to the screwed fastener. If we take third one, that is integrated fastener. For integrated fastener, the number of products will be reduced. That is only cup shaped product and then flat shaped product. And the flat plate and the cup shaped product need some design modifications. And the integrated fastener, it requires machine to secure heading the fastener. So we require additional machine investment for this. And if you required the fourth case study, there is only two components. By interference fit we can able to join, but it also required machine to press the part into the flat plate. So additional machine is required. It leads to investment for the product. If you see the last case study, only two parts is required. There is an integrated fastener. There is no shaking of products, but that it will be also a hand pressed one. So if you see the compared to all the four, if you see the fourth one, the fastener is not required. It is self fastening, and the number of components also it is minimum, and it will be assembled manually. So the assembly time is also less, number of components is also less. So it ultimately leads to reduce the product cost, and it will also reduce the time to market. So this is the DFMA will do for a product. So the next another one example is this is an diaphragm assembly. If you previously if you see the n number of components, at least 6 to 7 components it will be there. Now it will be converted into a 2 components. If you see the if you already we have obviously see this spoke wheel, and then nowadays we will be completely move on to the alloy wheels. So number of spokes in the wheel and the number of alloys in the wheel. You see by using a casting we will be using it is a single product. There is no assembly of components, and the manufacturing cost and the manufacturing time, the time to market also very less when compared to the spoke wheels. And if you see the mouse, if you see the previous you will be using a ball mouse. Nowadays we will be using the optical mouse for further assembly. So the number of time it will be reduced when compared to the optical mouse and then ball mouse. The number of components will be reduced. The number of components, assembly components will be reduced, will leads to the reduced in lead time for a product. Next, design for manufacture. So design for manufacture, it will produce the easiness in manufacturing the product. So there are some guidelines to get this easiness in manufacturing. We will see that guidelines one by one. If you see this product, there is a big cup shaped, and this product requires 3 components. One is that handle, the next one is that locking, and then next one is that bottom cup. If you manufacture in a single component by molding, the number of components will be reduced and the assembly time also will be reduced. And then the first guideline for design for manufacture is minimize the part count by incorporating the multiple functions into a single component. If you see the second component, we can able to assemble this one and then this one by using a screw fastener. Instead of screw fastener, if you take the fastening, that is press fit, we can able to reduce the number of components. If the number of components will be reduced, it will lead to the reduce in assembly time, reduce the product cost, and reduce the time to reach to the market. The second condition is modularization. Modularization means instead of separately assembled, separate parts is assembled into a single component, we will be modularizing this similar components into a single one, multiple components into a single one, and then assembled. If you see the previously, if you see the battery, if you put 6 batteries here, the separately 6 batteries assembly time is increased. Instead of integrating into a single battery, the assembly time will be reduced. And then design should allow the assembly in open space, not in a confined space. If you see here, there is an open space, there is no open space, it is a confined space is there. The screwing in a confined space will lead to the increase in assembly time. If we are easy to screw, the assembly time will be reduced. It will lead to increase in reduce the time to market. So this is what the design for manufacture will do for a product. If you see here, the parts should be easily indicate the orientation. If you want to search the orientation, it will also increase the time to assembly. And these are several insertion technique. There will be no sharp corners to insert the product. And here if you see, there is no sufficient length to correctly point out this bottom location. If you have sufficient height, you can able to easily insert the pin into the hole. And then we have some self-locking alignment for the multiple components. If you see here, there is self-locking alignment. This pin is a self-locking alignment, and here this slot is a self-locking alignment for this fastener. And here everything will be similar. That is easy to assemble. That is a self fastener, and this one will be a bolt and nut. This bottom nut. It is difficult to assemble for the particular component. The counter sink and then counter bore will be have to produced to easily assemble the internal sections of the product. And if you see that the fits will increase, how the fits type of fit will increase the cost. So basic snap fit will the minimum fastening method to that is also in terms of cost also. The second most is plastic bending, this is riveting and then screw. It will takes more amount of time, and the more amount of time will lead to increase the product cost. This is some of the graph that the Allen screw will be having. And this is the most important graph, that number of threads and then operation time. If you take the slotted head, the number of threads, if it is a very minimum thread, it will take operation time will be very less. If you take 8 as a moderate thread for all the things, if you take slotted head, it will consume more time. If you take the Philip head like this here, it will consume very less time when compared to the slotted head. If you take Allen screw, if it is a most less time when we operate it manually, it takes less time compared to other the slotted head and Philip head. If you go for power tools, this slotted head is the very efficient timing for assembling the product. If it is a manual, Allen is the best one. If it takes the power tools, the slotted is the best one for assembling the component. These are some of the fringe types, and then these are some of the guidelines for this the things. If you take the modelize, if you take TV also, there will be some red, yellow, and then white. So there is a Pocoyoke technique, that is zero error technique. So this is the thing for fastening. There is a provision for a fastening, and then very hard components we cannot able to design. And then if you see the fixture here, we need to able to tighten the 6 screws to fix this component. Instead of this one slotted means it is easy to assemble this component and standardize the component. We can't able to use the unstandardized component for this assembly here, because we can't able to identify if you want to identify each and every fastening places for identify the screws, it will consume more time. If it is a standardized, we can use all the screws for all the fastening areas. This is a modernization example. This is a color identification, from material color identification to differentiate the product. And this is providing the hub to prevent from nesting, design the product based on the nesting. And the design parts with orientation features, which we have already seen. And this is an Allen screws to fasten it. And this one will be a design that mating parts for easily insertion. We have to give some provision for inserting components. And then this is a design, first part is a larger, and second part will be a smaller when compared to this other parts. And then insertion at the top, every insertion has to be from the top, not from the side or from the bottom, because it will take to identify where the insertion area is. And then there are some other guidelines also there for joining the components. These are some of the example. For this, if you see the riveting to the component, the screwing the components is very difficult in this confined area. If you modify the design like this, it is easy to assemble the component. Same like that, the assemble the components in the flat area is very easy when compared to the inclined portion. So we have to modify the design. And then in the dynamic condition also, this will give more stiffness, rigidity than this inclined portion of the product. And then there are some approaches to attain these type of guidelines. One is standardization, next one is group technology, next one is value engineering, and the comparison of materials on cost basis. So this is what about the design for manufacture and assembly will be. So thank you.